Hello, this is 2-2 section. This will be over the course of a couple days, and this concept is basically the course for the whole semester. This vertex formula, we're going to keep on kind of working with the basis of parent functions based on this formula. So when you transform a exponential or a logarithmic eventually, this quadratic, so they all have the same type of transformation. So this will shift it left or right inside, and remember, inside flips. This will shift it up or down. So outside the parentheses affects the outside, inside the parentheses affects the inside. This A value is going to cause it to stretch if it's bigger than 1, or compress if it's less than 1. And if it's negative, then it will reflect. Okay, so these were our warm-ups on Monday, so be really careful. Inside, a lot of people think this shifts right to, but it's not, based on the formula and based on sort of this concept of zeroing it out. You're going left to. This is right 3, so you would just go ahead and follow x minus 3 squared plus 1. And then this third one, and I know we did this in class, but it reflects. So we're going to go to the steps concept. I'm kind of going back to my roots here. MVP and what we've been doing last week is sort of really hitting the parent function. But here's the parent function. 0, 0, 1, 1, 2, 4, 3, 9, etc. But where these steps come in is the difference between those three. So the difference between 0 and 1 is obviously 1, 3, 5. So, I mean, this continues, but the basic transformations, you can go over 1, up or down, 1 times A, 3 times A, 5 times A. So it's just going to be a little bit easier, I think, for a lot of you, because this is kind of a tough table to navigate every single time. Okay, so some classes took a few notes on these. Another one did not, so you'll have to bear with me for some of this page, and then I'll just kind of go step by step. So again, two of my classes had it, but the third one didn't. So if you're in the class that did not and you want to pause this, please do so. And just if you already had it, then here you go again, yay. So again, that's your vertex formula. We've already had it on a take-home quiz. We've had it all through section 2.1 last week. Now we're in 2.2, but it's a lot of stuff, I know. So basically, A is bigger than 1, it's stretched. Less than 1, it's a compression. So really kind of keep an eye out for those values. Again, if you need to pause this at any time, do so. So I'll just show you this graph, and then I'll just start doing some more step-by-step. So, and then I can get rid of this tape because it will not stop. Okay, so this is... A is 2, so it tells me it's going to be a stretch. The vertex is 5, negative 7, so that's going to be a shift right 5, down 7. And the axis of symmetry is going to be that x coordinate. Don't forget x equals 5. It's a line, so you have to make it a vertical line. X equals 5. And when you graph, please make it a parabola. Don't make it pointy. That looks like absolute value. Don't make it, you know, wider than it needs to be or anything else. So be careful. Okay, so now I'll start doing a few step-by-step. Okay. All right, so number 6. Y equals negative 1/2 x plus 2 quantity squared plus 5. Let's see here. This is your new best friend. Okay, so I can tell you right here that A is 1/2. So that is going to be a compression, which means it makes it wider. This negative means it's going to be a reflected. So open upside down. And what else? This is going to be a shift left 2. This will be a shift up 5. So the vertex is -2. Chew! Excuse me. And God bless me. Because even if you guys were all on video, I don't think anyone would unmute and say God bless you. So I'll just say it to myself. Okay, x equals -2 is the axis of symmetry. So don't forget to answer all the questions. All the goods. Okay, so we're going to kind of start to omit these tables because I went rogue and we're going steps. All right, so the steps are 1A, 3 times A, 5 times A. What that means is you go to the right 1 and then up or down that first step. Then you go right 1 again and you go up or down the next step. So when we did it before with the parent graph function, you had to keep going back to the vertex and going like using the 1, 4, 9 values. So this is just a little bit easier when you're graphing it by hand. If you're using a graphing calculator, obviously that's all stats, what you can do to check it. But number 1, you won't have time. Number 2, a lot of times you have to change your window. And like I said, because these transformations will be in effect for everything, logs, exponents, it's just good to know it. So that's why. Okay, so this vertex is -2, 5, 1, 2, 1, 2, 3, 4, 5. And the steps are 1 times -2, which is -2. 3 times -2, which is -6, and 5 times. Now they continue, but we only need about 2 or 3 points to make our parabola. Okay, so from that vertex, I'm going to go out 1, down 2. From that next point, right 1, down 6. 1, 1, 2, 3, 4, 5, 6. Now, I'm just reflecting it. So in class, I've been saying that you just need to reflect it. I could go down 10, but you kind of get the idea. What I don't want you to do is if you have these 2 and then all of a sudden you like make some gobbledygook. No. Keep it straight. You just made 5 points. So connect your 5 points and you should be good. All right. So some kids get grumpy when I take off points because I'm like, no, it's different. If it's not that skinny or if it's not the fatness that you might have drawn it, then you've got to fix it. All right, so this vertex occurs at a maximum. Okay? Occurs at a maximum. Why? Because it's at the top. Okay, I'm going to kind of scoot along, otherwise this will be an hour-long video, and I don't want that. But again, anytime you want to pause, you can pause. So transformations, A is 1/4, so that means it's going to be a compression. Shift left 3, be careful, and down 6. So that makes the vertex -3, -6. Now the vertex is an ordered pair, so please put it in parentheses. The axis of symmetry is a line, so you must have x equals 3. Must have x equals whatever that is. In this case, it's -3. I think I just said 3. All right, so from the origin, I'm going left 3, 1, 2, 3. Oh my gosh, these cannot get any tinier, I swear. And then 1, 2, 3, 1, 2, 3, 4, 5, 6. All right, so A is 1/4, so I'm going to go 1A, 3a, 5a. Now, sometimes kids get grumpy because they're like, I don't know fractions. In general, I mean, look how microscopic these are. It just kind of means like from this point, I'm going up a fourth. So just don't go more than halfway. A quarter is 25 cents. Up 3/4, so that's going to land on the 1. So one of my tricks is to like actually plug in a point just to kind of see if you're in the right direction. Like let's say I plugged in 1 back into the graph or into the equation. So I would say 1/4 times 1 plus 3 squared minus 6. 1 plus 3 is 4, squared is 16. 1/4 of 16 minus 6 is 4 minus 6. Oopsies. Is -2. So at 1, the output would be -2. So if you don't want to keep using steps, you can just kind of like ballpark a point there, and then you can reflect it. All right. Okay, then we have another. Now, if you want to pause the video and try this, I would highly recommend. Okay, and then you can hit play again and it'll be done. So I would recommend that, or you can fast forward unless I put it on an Edpuzzle, then I know that makes a lot of you grumpy. But yeah, that's all I have to say about that. All right, so transformations. Now we're getting quicker. It's going to be narrower. Why is it going to be narrower? We call that a stretch because a is equal to 3 and 3 is greater than 1. You've got a reflection. Why is it a reflection? Because of the negative. And then we've got a shift right 1 and up 9. Okay? So that makes the vertex 1, 9, and it's going to be at a maximum. 1, 2, 3, 4, 5, 6, 7, 8, 9. And steps are going to be 1a, 3a, 5a. A is -1, or -3 rather. Now here's the thing. A, like just the pure absolute value of the number, technically A is -3, which means it's going to reflect. But the absolute value is what's going to tell you about the stretch. When you plug it into your steps, it'll take care of that. Okay, so that means I'm going to go right 1, down 1, 2, 3, and then I reflect. Out 1, down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then reflect. 1, 2, 3, 4. Now, again, that's enough to make a parabola as long as you connect your points. Don't leave these dots hanging out there in space. And that vertex occurs at a maximum. Okay. So again, if you paused and you're checking in it, hopefully you're doing great. If you need to pause and if it's a class time, then obviously unmute and ask a question. And otherwise, I'll continue on my journey. Okay, so this next batch is write the equation of each function in vertex form. Okay, so I'm going to tape this because it's kind of moving. Talk to myself a lot, I know. All right, so this vertex, so the key to writing the equation is to find the vertex. Find vertex. And then you can establish, that's an ugly, let me print, establish the A value. Okay, and the way you do that is to see what happened from the very first point. Okay, so here's my vertex at -3, -1, 2, 3, 4, 5, 6, 7. All right, so the vertex is -3, -7. So if nothing else, I can start my shell. I don't know my A value yet, but I know that my shell is going to tell me it's x plus 3 squared minus 7. Okay, again, y equals ax minus h squared plus k This is something that you have got to do, because it is all semester. All right. So, and again, be careful. Minus -3 is plus 3. Plus -7, minus 7. So when I go right 1, I only go up a half. When I go right 1, it looks like I go up 1 to 1.5. Okay, so it's not the best. If you wanted to like see what happened at 0 and you got an output of 1, sometimes people can do that. Let's just practice that. Let's practice some algebra. -1. So I'm looking for the A value, and if I know that my output is 0, -1, like I'm essentially plugging in an ordered pair. So I don't know A. 0 plus 3 squared minus 7. I miss solving. Don't you guys miss solving? So when I add 7, I get 6. So this is a super stinky A value. All right. So I know kids will be like, I would never get that on my own. I'm kind of with you. That's a yucky first example of trying to find the equation. Because if you thought it was a half, the reason I knew it wasn't a half is because then the next one should have been right here, and it kind of misses it. So if A is 2/3, it's 2/3, and then 2. So 1, 2. So anyways, not fun. So don't worry too much about that guy, but at least you know that it opens up. Now this one opens down, so let me make a red mark here just so it pops. So y equals negative something. And this one is a little bit clearer. It goes out 1, down 2. All right, so on a quiz, I would make it clear, and I'll try to make it cute. I mean, it might be a 1/2. 2/3 was kind of a stretch. Okay, so then the vertex, it looks like is 1. I'm hoping that's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if the vertex is 1, 9, it's at a maximum. This vertex is at a minimum. Oh, and this axis, I don't know if I have to do the axis of symmetry, but might as well, right? So x equals, oh no, you just had to write the equation, but now I'm on a roll. Okay, so then x minus 1 squared plus 9. Okay, now this next one is a table. So I guess I could leave that all there so you can keep watching. Okay, so this table, you'll start to see a pattern. Like here's 22, 12, 6, 4. 6, 12, 22. So these guys are the same. These guys are the same. Repeat. Repeat. What doesn't repeat? The vertex. So that tells me that that's the vertex. Now, if it's the vertex, then the next point should be up or down 1. And it's up or down 2. So because it should go right 1, up 1. It doesn't go up 1, it goes up 2. So that tells me A is positive 2. So now when you write the equation, positive 2 goes out in the numerator. X minus 5 squared plus 4. This guy. Again, if you need to pause, pause. If you need to unmute, unmute and ask a question. All right, so this is -4, -2, -4, -10, -20, -34, -52. I only see a repeater here, but that's all I need. So this is my vertex. So I've got y equals something times x plus 8 squared minus 2. Okay, so that's, your vertex is easy, you guys. So then you can put that in. This A value is where you get the goods. So you really have to be careful of how to find that. And hopefully now you're like, oh, okay, so it should have been up 1, right 1, up 1. Well, this one went down 2, and it went down 2. So hopefully you're shouting in your seats right now. It's negative 2. All right. And if you need to sketch this, and just sketch it. So here's negative 9, negative 4. Here's negative 8, negative 2. Here's negative 7. Oh my gosh, that was a ding dong move. Okay, sorry, this is the end of the school day, and I'm like, not cool. I went up instead of down. All right, back to my sketching it. Negative 9, negative 4, so 1, 2, 3, 4. Negative 8, negative 2. Negative 7, negative 4. So even a sketch tells you that it opens down. All right, if you wanted to sketch this puppy, here's the vertex, 5, 4. Again, it's a sketch. Don't make tick marks, just be quick. 4, 6, and 6, 6. So that's your thought process when you're sketching. If you're sketching, you're just like, oh, I wonder what that looks like. Don't have a full-on graph. You'll never finish. Okay. Hopefully you're not on Cami for this because I know it's really frustrating. So this is where I'm going to pause for now. You're going to practice, okay? And we will commence a little bit. Practice, write the following, and then homework. All right? So if you want, you can pause. If you're up for keep watching, then keep watching. Welcome back. Okay, so now we have graphing quadratic functions practice. So if you were in front of me, I would make you guys practice. You're not in front of me, so I will do it. I'm going to assume that you're going to keep pausing because that's how you're going to get better. It's not just about writing down what we're writing, but learning it as you go. And because you can watch this at your own leisure, you should be practicing it. Okay, so graph the function by showing at least 2 points on each side of the vertex. Describe the transformations needed to move it, then find the key features. Okay, so hopefully you're getting to be an expert. We know that negative tells us reflection. We know that 1/2 tells us compression. X minus 2 squared is right 2. And plus 4 is up 4. So the vertex is 2, 4. Axis of symmetry, I'm going to put this in red so it pops. X equals 2. Is it a max or a min? Well, you tell me. Reflection. So that means it's going to, this is what your thought process is, that it's going to open upside down. So it's going to be a maximum. The domain is always all real numbers for these parabolas that open up side by side. And the range, because it opens down, is going to be from minus infinity until I get to that y value and stops, bracket included. Okay, 1, 2, 4, 1, 2, 1, 2, 3, 4. So at least 2 points on either side. So if A is negative 1/2, 1 times A is negative 1/2. 3 times A is negative 3/2. So from that, I go out right 1, down 1/2, reflect. Out 1, down 1.5, reflect. Whee! Now, if you want to keep going, that's fine, but this is what I said earlier, that don't get all crazy and make something that's not accurate, and then you'll lose a point. So if you're going to do more points, they have to be accurate. Okay? So again, sometimes I'll just plug in a point and literally plug it in and see what I get. Don't pick anything too crazy. Like if I pick 10, 10 minus 2 is 8, squared is 64. Negative half of that is negative 32, plus 4 is negative 28. I'm going to be way off the grid. But it'll tell you that that's how slow that's growing. Okay? So, there you have it. All right. Scoot, 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 scoot. Graph the function, y equals blah, 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 by showing at least 2 points. Describe the transformations needed, then find the key features. Oh, we're getting to be such experts now. 2 is a stretch. X plus 1 is a shift left 1. Down 3. That means the vertex is negative 1, negative 3. Axis of symmetry is x equals negative 1. It opens up, so it's a minimum. If the word is here, then spelling counts. Domain is all real numbers for our parabolas that open up and down, and then the range is going to be from negative 3 to infinity. So include the vertex, but not infinity. Okay? So if you want to graph it first and then you're a visual person, that's fine too. So negative 1, 1, 2, 3. Okay? So A, let's see, 1A, 3A, 5A. Remember, that's what we're doing. A is 2. 1 times 2, 3 times 2, 5 times 2. So I'm going out 1, up 2, out 1, up 3, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And then up 10, but then I'll be off the grid. So I'm going to connect. And there you have it. So it's kind of a skinny graph. Why is it skinny? Because A is equal to 2. So it's a stretch. So you're like pulling on that rubber band. Right before you shoot someone with a rubber band, right? It gets long and skinny. All right, write the equation in vertex form. Oh my gosh, if anyone says, what's vertex form? You know that your classmates are going to say, what the heck? Where have you been, dude? Or dudette. All right, so A, x minus h, quantity squared plus k. So first thing you want to start with is the vertex. So hk is the vertex. So in this case, the vertex is 1, 2, 3, 4, 5 negative, 1, 2, 3, 4, 5, 6 negative, negative 5, negative 6. Then you have to plug those in to your h and k values. So I don't know my a value yet. I can pause, leave a space. X plus 5, because minus negative 5 is plus 5 squared minus 6. And then the a value, so if I went right 1, it's going to be some fraction. But then when I go right again, it ends up on that whole number. Alrighty, so right 1 up a half, right 1 up a half. Okay. I have to pause this for a second, sorry. Okay, all right. Okay, let me hit this again. All right. I'm sorry. I wish I could pause and it picked up, but it holds time. So I just had to return a message. Okay, so it doesn't quite go up a half. We could do the algebraic way again, and I would like to show you that a way. Like we know that 0, 0 is on this graph. So if 0, 0 is a point, I can plug it in. 0, I'm looking for A. It's sort of like when we're looking for the B, right? So if I add 6, 25A, this can't be right. What the heck? I was going to say 1/4, because then it would be up 3/4. 1, 5/4. Yeah, it's just a fourth. Maybe that's not 0, 0 over there. No can do. 1/4. All right, I know, I'm coming. Okay, I got to finish up. All right, so that's the answer here, okay? You don't, it's already graphed, so don't worry about that. And if this is bugging you, then don't worry about attempts. 0, 0 is not on that graph. But when we went out 1, up 1/4, out 1, up 3/4, out 1, up 5/4. So that's like 1 1/4, 7/4, etc. Again, on a quiz, would I put a fraction? Probably not, unless it was clearly 1/2 or something like that. Because on a graph like this, you can't see 1/4 or 2/3, and we don't have to do the algebra. Okay, write it in vertex form. You better be an expert at this by now, right? Okay, so pattern, 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 pattern leaves me with the vertex. So the vertex is HK, that's -3, 2. So far I know that it's going to be y equals something, x plus 3 squared plus 2. What is that something? So instead of going out 1, up 1, it went out 1, up 3. So that tells me that that's the multiplier, 3. And you can double check. Like, I mean, if you checked 0 again, 0 plus 3 is 3, squared is 9, 27 plus 2 is 29. Yay. Is that little guy right on the smack of that? Oh boy, hopefully not, but it probably is. All right, so that ends class practice. So again, I would have you pause this again. I'm not going to go through the homework right now. You can do this homework on your own. It's ready, set, or it's just the set and the go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 12 questions, all of which have been answered in some way, shape, or form via notes or video or whatnot. So homework numbers 1 through 12, and that is what you are going to submit to Canvas. All right, I hope you have a wonderful day.